In research, there are independent variables and dependent variables, and the distinction between the two is very important. Independent variables are conditions that cause the change in behavior. They are the cause. The dependent variable is the behavior that is changed, or the presumed effect. For example, masking noise as the independent variable may cause a change in auditory threshold, the dependent variable. Depending on the amount of masking noise, the auditory threshold will change. So as you manipulate the masking noise, you're going to measure a change in auditory threshold. There are also extraneous and nuisance variables that may affect the relationship between the independent and the dependent variable and may confound the experimental results. There are control variables, which are extraneous factors that are identified and kept constant so as to minimize their effects on the outcome. It is not possible to identify and control for all extraneous variables, but researchers will always try to keep certain factors constant. Every empirical experimental study will try to control for the effects of the testing environment, so all subjects will be in the same testing environment, all subjects will receive the same instructions, and certain subject attributes may be controlled for. It is impossible to control for all extraneous variables. With empirical, also known as experimental research, the experimenter manipulates an independent variable while controlling for other potential extraneous variables, and the experimenter then examines the effects of the manipulation on the dependent variable. With descriptive research, which is different from experimental research, we'll talk more about it in a few more slides, it's not possible for the researcher to manipulate the independent variable. And the independent variable is more of an attribute, a classification, and it is not manipulated. We can express an independent variable as an x and a dependent variable as a y, and then we can graph them. They can also be expressed as a mathematical function. If we know the value of the independent variable, then we know how it is related to the dependent variable. We can determine what the dependent variable is. We can also plot this graphically or use a simple linear equation. For example, y equals a plus bx. Here it's graphed. The independent variables on the x-axis and the dependent variables on the y-axis. The value of the independent variable increases from left to right, and the value of the dependent variable increases from bottom to top. That's the formula, with b being the slope of the line, which indicates how fast the dependent variable increases as the independent variable is increased, and a, the value of y at the point where it intercepts the y-axis.